Alright, hey guys, so basically for today, we are going to learn on forces. It'll be our fourth chapter in semester 1. Okay, let me just explain a little bit about forces. Forces usually will be the calculations, usually will also follow like what we have learned in chapter 2 and so on. Angles, everything are included. But right now, we are only focusing mainly on forces. So, in order for us to focus on forces, we need to know types of forces that there are and all the concepts of how the forces work. So for today, I'm going to introduce to you guys 5 different types of forces. And today we'll do our own notes. Everything is going to be about the basic concepts. All right? Okay. So now, what we're going to learn for today is forces. Okay. Let's move on to the types of forces. Okay. Before I move on, let me just reiterate or restate that forces is a vector quantity, which means the whole chapter for chapter 4, your calculations, everything need to include positive, negative. Please make sure you guys know which is positive, which is negative, as we have learned this many times over and over again. The moment it's going left and down, it's negative. The moment it's going up and right, it's positive. All right, okay. Now, let's move on to the types of forces that we have. These are the basics. Number one, we have weight force. Okay, so what is the symbol of weight force? So usually we just use W. Okay, we can denote it as W. So what is the definition? Okay, please bear in mind definitions and concepts are very important for number one, calculation, and number two, for your US, ujian summatif. Because for this test, it will be calculated for your final pointer and it'll be accumulated. So on this test, they will be asking mostly on definitions, concepts, and basics. Okay, all right, let's move on. What are weight force exactly? Weight force is a force exerted on a body under gravitational field. Okay, so basically, weight force is like weight. What do you understand by the concept of weight? So it's all depending on planet Earth. Okay, we have gravity, right? Gravity is gravitational field over here. So whatever floating will go down no matter what because of gravity. You throw a ball onto the air, it will still come down. Why? We have gravity. So gravity acts where? It acts downwards. So no matter what happens, it still acts downwards. All right? Okay. Now, let's move on. Else can we actually talk about weight force? Weight force is directed towards the center of the earth. Okay? The SI unit is kilogram meter per second square or Newton. Okay, in this chapter, just keep it simple. Force, everything is Newton. Just make your life easier. Right? Okay, so what is the equation? We have W equals to mg. Mass over here, it's mass, it's not weight. Mass must be in kilograms. G over here is gravitational acceleration. You guys know the value of gravitational acceleration is 9.81. Please bear in mind, you have the negative. Why? Because it's always moving downwards. So it's negative 9.81 meter per second square. All right. Now, let's have a look at a couple of cases of weight force. Case number one. Let's say an object is on a desk or on a table. Weight force is directed where? It's always directed from the center of the object. Remember, center of the object downwards. What is your label? W. Case number two. Let's say the object is on top of an inclined plane. What is the weight force? From the center of the object. Okay, part ni tak kisahlah dia incline berapa darjah pun, weight force is always still downwards. Your symbol will be W. Okay, next, let's say something which is hanging. an object which is hanging, okay? Let's take a box which is hanging. Where is the weight force? It's still downwards. Okay. Those are the main concepts of weight force. Now, let's move on a little bit detail on weight force. Okay. I wouldn't touch much on calculations today, but let me just explain the basic concepts. Remember, weight force over here in case number 1, only y component. Why? Because no x component, right? You guys know very well. The moment is 90 degrees is only one of the components. You choose, okay? This one also y component. But case number 2, I think it's quite obvious. There is x and y component because it is at an angle. So you guys have to resolve. In order to calculate the angles and so on, calculation will move on to the next session. All right? Okay. Any questions before I move on into the second type of force?
No.
All right. Okay. So everything's good. Now, let's move on to the second type of force. The second force is called tension. So it's denoted by the letter T. All right. Okay, in this chapter, let me just remind everything is vector quantity. We are talking about all forces. So, it's not really necessary for you guys to put yang arrow dekat atas ni tau. Tak semestinya. Because people know very well that this is a vector quantity. So, you can just write it simply T. Okay. Now, what is tension force? Tension force is a pulling force that is directed away from the object and attempts to stretch or elongate the object. Okay, let me just repeat here. Tension force is a pulling force that is directed away from the object and attempts to stretch or elongate the object. Basically, tension, you put tension on something, it's you start to stretch something. That is tension force. Okay. Tension force is also a vector quantity. Next, the unit. You can use kilogram, meter per second square, or as simple as it is, Newton. Okay. Now, let me just explain a couple of cases for you guys to identify tension force. Number 1, let's say an object is on a table and there's a string. All right, okay. Let's say there's an object on the table and a string is actually pulling the object, okay? A string is actually pulling the object. Okay. As per the definition atau mengikut definisi, we are talking about a pulling force that is directed away, right? Jadi, the moment the object moves whatever way and there's a string attached to it, the force is always opposite the object. Okay. Now, itu part physics, but let's have a look at part logic. Let's say the object is moving that side, right? So definitely, let's say someone is actually pulling the particular object. So the force is directed towards that someone kan, towards orang ni kan. That is the logic actually behind why the force is directed away from the object. Ini just case logic lah so that you guys understand quite well. Okay. Number 2, let's say an object is hanging. Okay. Yang ini string kan. Where is the force going to go? The force is going to be directed away from the object. Remember, away from the object. Okay. Number 3, let's say we have a pulley. You guys know what's a pulley, right? Okay. A pulley, we have object A and then we have object B. Okay. Where is the tension force? Okay. Kali ni ada dua object, right? Jadi, dua-dua akan ada each their own tension force. Ini ke atas, yang ini pun ke atas. But untuk dua objek berbeza. Please bear in mind. Tapi untuk case tadi, weight force, weight akan still going down. Okay? Weight akan still going down. The moment something is pulling, that is a tension force which is directed away from the object. Okay, now, let me explain or let me give some examples of things. So usually, kalau nampak keyword macam ni, string, rope and cable, confirm akan ada tension force. Okay, you guys have to know and identify what kind of forces are there because it's very important for your calculations. Alright, any questions before I move on to the next type of force?
No.
Alright, okay. Now, let me move on to the third type of force. The third type of force is called a normal force. Okay, ini juga dipanggil sebagai reaction force. Sometimes they'll just confuse you and just use reaction force. You guys have to know that normal force is the same thing as reaction force. Okay, ada dua simbol. Kalau guna nama normal force, you have to write N. Kalau guna reaction force, kena tulis R. Tapi benda sama je ya. Okay. Now, normal force. What is a normal force? A normal force is a reaction force that exerted by the surface to an object interact with it, and the direction is always perpendicular to the surface. Okay, let me just repeat. Normal force is a reaction force that is exerted by the surface to an object, which interacts with it, and it is always perpendicular to the surface. Okay, don't worry about this long definition. I'll get back to you very soon on what do they actually mean over here, okay? Please do remember, normal force is also a vector quantity, and the unit, as long as it's force, it's still Newton. N capital. Tapi if you want to ejakan, N dia kecil. Tapi sebagai simbol, N capital. Okay, what do they actually mean right here? Let me just explain to you guys. Okay, let's say an object is on a surface. Remember, keyword here is surface and perpendicular. The moment there's a surface, normal force anda adalah 90 degrees kepada surface yang tu. Maksud dia, ini objek kan? This is your normal force. You guys know what is normal kan? Normal line, you guys learn a lot of stuff. Normal line, tangent line, ini semua mathematics. Normal line is anything 90 degrees from the surface. Ini adalah surface, right? Yang bawah ni. Apa-apa 90 darjah dengan surface tu adalah normal force. Itu case pertama. Case kedua, let's say it's on an inclined plane. Okay? Ini adalah your surface kan? Okay, the moment an object touches a surface, automatically anything which is 90 degrees, it should be 90 degrees, okay? Okay, I'm just roughly drawing here. It should be 90 degrees. So usually it should be somewhere here. Let me just redraw it a bit. It should be somewhere here. 90 degrees, okay? So your name or symbol over here will be N. Okay, 90 degrees towards the surface. Okay. Number 3 is when you have an object hanging. Okay, when you have an object hanging, yes, you tahu ini adalah tension force. Tapi, adakah objek yang tergantung tu touches a surface? No, it doesn't touch a surface. It's on air. The moment it's on air, there is no normal force over here. Please bear in mind, it must touch a surface. And the moment it touches a surface, dia adalah 90 darjah kepada surface tersebut. Yang keempat, ini adalah comparison normal dengan weight force. Benda yang sama, situasi yang sama, inclined plane, objek kan? Okay, ini adalah surface kamu. Weight force is dari tengah directly down to planet Earth. No matter what, directly down to planet Earth. Ini adalah weight force. Normal force dari objek kepada surface. So this will be your normal force. Okay? Please understand and please know when to differentiate what. Okay guys, any questions before I move on to the next force?
Uchi?
Yes.
Can you explain the third one?
Okay, the third one. Sure. Let me just write it in green color, okay? For the third situation, let's say an object is hanging, okay? Kalau dia hanging, is it touching any surface? No, it's not touching any surface. Number two, it's hanging kan? The moment it's hanging by a rope, this is tension force. Okay. Jadi, is it touching a surface? Which means objek tu perlu berada dalam situasi begini atau begini. Unfortunately, it's not. It's not touching any surface. It's basically on air. Dia di udara saja. But it's hanging. The moment that is happening, this thing is tension force and there will be no normal force. Tiada normal force. Kenapa? The definition says exerted by a surface to an object. Adakah ini surface? No, it's a string. Surface means a ground like this, a platform, the table, whatever which is flat, that is surface. All right, do you understand?
Yes.
Okay.
Thank you.
All right, no problem. Now, shall we move on to the next one? Okay. Now, let's move on to the next type of force. The next type of force, which is the fourth force, is frictional force. Okay, frictional force ni a little bit technical sebab ada dua jenis frictional force. Okay, let's have a look what is frictional force dulu. Frictional force is a force that resist, okay? A force that resists the motion, basically menyekat lah, the motion of one surface relative to another with, to another with which it is in contact. Okay, let me just repeat, yeah. Frictional force is a force that resists the motion of one surface relative to another with which it's in contact. Maksud dia, okay, no need to worry about your language or so on. It's basically what does it mean is, let's say ada surface, ada lagi satu objek dekat atas. The moment the surface is rough, that is frictional force. That's what they mean. Okay, jangan risau sangat. Okay, now let me just put on the keywords over here on in blue color, okay? Rough, okay. The moment a question says the surface is rough, dalam ayat tu, surface A is rough, automatically frictional force akan hadir. But the question says the surface is smooth, automatically frictional force, there's no frictional force in that question, okay? Same thing just now. The moment an object is hanging, tiada normal force. Tapi ada apa? Tensional force. Sekarang, kalau question tu bagi rough surface, automatically akan ada frictional force. Tapi kalau question tu dah cakap, the surface is smooth, then you don't have to take into account frictional force. Basically, ignore frictional force. Okay? Maksudnya dia takkan exist dalam calculation you. Calculation, don't worry, we'll explain and discuss more on the next session. Okay. Let me just continue over here. Over here, frictional force is directly proportional to the reaction force. Reaction force tadi apa? Reaction force is actually your normal force kan? Okay, what do they mean directly proportional? Okay, let's say an object is here kan? Tadi kita belajar apa? Normal force is 90 degrees towards the surface. Okay? Frictional force is basically, let's say the object is moving to the right. Frictional force opposite to the left. Okay, kalau frictional force is to the left, kan sini 90 darjah. That's what they mean lah. 90 degrees towards normal force. Itu je. That's what actually they mean. Okay, frictional force, you cannot write like this, you know, F huruf besar and so on. There is special symbol. Now let's discuss. Ada dua jenis frictional force. Number one, F kecil and K lagi kecil daripada tu. Okay? So basically this is called kinetic friction force. Okay? And number 2, we have Fs, static friction force. Okay. There's a main thing and a major thing that you guys need to know lah over here. Kalau Fk atau kinetic friction, the object is moving. That is number 1. Belah sini, kalau frictional force static, Fs, the object is not moving. Static kan? So not moving lah, basically stationary. Okay, kalau dia cakap perkataan stationary, static, not moving, those are all keywords untuk Fs. Okay, kalau dia cakap in motion, the object is in motion, the object is moving to the right, the object is moving to the left, those are all kinetic friction force. Tapi these two only exist kalau the surface is stated rough. Alright? Okay, that is number 1. Number 2, tengok arrow betul-betul. Kalau dia tak cakap apa-apa, tapi let's say dalam objek tu, dekat atas dia ada tunjuk macam ni. Maksudnya objek tu bergerak ke kanan. Definitely it's kinetic friction force. Kenapa? Kinetic energy is for something which is moving kan. So over here is kinetic friction. Alright? Yang ini is like this. But jangan terpedaya dengan gambar rajah saja. This side you can identify clearly that it's moving sebab ada arrow. Belah sini baca balik soalan betul-betul. Kalau betul-betul dia cakap stationary or not moving, baru recheck dan only masuk static friction. Okay. Now, ada formula untuk frictional force. Formula dia adalah F kecil. It can be used for both, Fk, Fs, both same formula. Equals to mu n. Okay. N ni adalah normal force kamu atau reaction force. Mu ni apa? Mu ni adalah coefficient of friction. Okay. Mu ni selalu akan diberi dalam soalan. Dia macam list of constant but not really list of constant. Different object has different coefficient of friction. That is number 1. Number 2, sometimes dia akan suruh cari F friction and N, lepas tu suruh cari coefficient. So I think you guys know, cari ni, lepas tu push this that side, you'll get your coefficient. Okay, calculation jangan risau, we'll hit on calculation very soon. Okay, this is the basic formula for this force specifically. Okay, now let me just explain a couple of examples for this particular force. Let me just use a black color. Okay, I'll just draw over here on the top right. I think this is quite direct sebab kalau force bergerak belah sana, belah sini frictional force. No matter where, kalau force tarik pergi atas, frictional force mana? Opposite. Itu je. That's the basic and simplest concept of frictional force. Okay guys, any questions before we move on to the next force?
No.
Alright.
No.
Okay. Let's move on to the last but not least force, which is external force. Alright. Number 5, it's external force. Okay. This force is the one that you guys can see dari dulu lagi. Dari sekolah menengah form 4. F rho besar. That's why tadi, kinetic friction, you guna F rho kecil. External force is F rho besar. So basically, what is external force? External force is basically a push or a pull. Push or pull. The moment there is a string, remember, the moment there is a string, that is tension force. The moment someone is pushing an object atau there is arrow like this, that is external force. Okay? Dia beza tau. Kalau ada string dekat sini, that is not external force. No. But the moment there is no string but the object is in motion, that is external force. Basically, nak cakap senang cerita, orang tengah push objek ni belah kanan. Itu je. Senang. Kalau belah kiri ada seorang lagi, belah kiri. That is external force is one of the simplest force lah for you guys to take note and understand. Okay, remember external force ada dua. Satu push, satu lagi pull. Remember, kalau pull with a string, that is tension force. Tapi pull an object, atau nak senang cerita, a man pulls an object. Basically, he grabs the object and tries to bring it over. That is external force. Ada beza tau. Please make sure you guys take note of the keywords yang cakap tadi, rope, cable, and rough surface and so on. Alright guys, any questions before I move on and introduce to you guys a new thing that we're gonna learn here?
Dah.
Alright, okay. Now, the fun part about all these forces is for you guys to create a free body diagram. So, what is a free body diagram? Okay, a free body diagram is basically dia macam representative. Dia represent segala force dalam motion tersebut. Okay, let's have a look at a couple of free body diagrams. Number one, I'm going to give you guys a couple of examples. Number one, let's say an object is moving here, okay, belah kanan kan? Tapi dia tulis sini terang-terang F. Maksudnya ni apa? External force, bukan tension force, okay? Dia tak cakap apa-apa pun. And then dia tulis macam ni, acceleration to the right. Okay, remember kalau dalam chapter ni, acceleration to the right, acceleration to the left, maksud dia the object is moving. Sebab dia tak logic if we call velocity. Kenapa? An object is moving from 0 to 20 meter per second, that is acceleration. Because mula-mula objek tu static atau stationary, lepas tu baru dia mula bergerak. Macam mana dia mula bergerak? Sebab ada force. Okay, itulah logik belakang dia. Kalau dia tulis acceleration belah kiri, maksudnya belah kiri lah. Acceleration dia is moving to the left. But in this case, is moving to the right. Okay. Now, ini adalah rough surface. Okay. Remember, satu rough surface. Rough surface. Number 2 ada external force. Number 3 acceleration towards right. Okay. Number 4 we have a surface. Kenapa penting tahu ada surface ke tidak? Kan normal force kita belajar hari tu mesti ada surface. Okay. Now, how do you actually draw a free body diagram? Free body diagram is actually a representative. Object ini, okay, please listen carefully. This object is represented by a dot. Okay, a dot. Now, let's go one by one. Ada rough surface. Kalau objek belah kiri, it's moving to the right. Rough surface, frictional kinetic kan? So it's moving to the left. So ini objek, kinetic friction towards left. This is a diagram to represent forces only. Next, ada objek, ada external force ke kanan. External force ke kanan. F huruf besar. Next, ada objek, ada surface. The moment ada surface, normal force ke atas. Kenapa? Because the object is resting, so it's directly proportional atau 90 degrees. Normal force. Next, kalau ada apa-apa objek dalam muka bumi ini, of course ada apa? Weight force. Kenapa? Weight force merupakan daya tarikan graviti bumi, bukan manusia yang kontrol. So, confirm ada weight force. Next, jangan lupa acceleration belah kanan. So, acceleration belah kanan. Okay, before I move on to another example, do you guys understand this?
Faham.
Alright. Okay, now let's move on to another example. Okay. In example number 2, let's say an object is on an inclined plane. Okay, an object is on an inclined plane. Same thing, force ke atas, acceleration ke kanan, and then definitely the moment you see an inclined plane, of course ada angle kan. Okay, jangan get confused with the angles and so on. Draw free body diagram dulu. Macam mana nak draw free body diagram? Okay, konsep untuk draw free body diagram paling senang ambil daripada surface. Dia macam ni kan? Surface dia dekat sini kan? Copy paste. Surface is over here. Okay. Next. Normal force ke atas. Kenapa? Surface is over here. Normal force is 90 degrees towards this surface. Next, rough surface. Sorry, I didn't tell you guys that this is a rough surface. Okay, the moment it's a rough surface, object moving to the right, kinetic friction to the left. To the left, FK. Remember, dot kena besar sikit dekat tengah-tengah because this dot represents the object, kalau tidak salah. Then, towards the right, ada apa? External friction. F, huruf besar. And jangan lupa your acceleration is juga towards your F. Next, sini ada angle kan? Okay. This is the time where you know very well object is over here. Tapi weight is always downwards kan? Just draw downwards. Don't worry. Wait. Okay. Now, this will be your free body diagram. Jangan lupa, we have angles. Yes, we have angles. Tapi when it comes to calculations, you have to include the angle. Right now, in free body diagram, tak perlu include the angles. Okay? In calculations, I will explain further on how to do the calculations in the next session. For this one, do you guys really understand this free body diagram? Any questions on this? Okay. Now, the last but not least example, okay, these three are the main and common examples that you guys will see in your examinations. Jangan risau, takkan keluar super complicated. Okay. An object is hanged, okay? An object is hanged. Okay. Ada dua jenis situasi. Number one, number two. Number two is an object is hanged by two strings. Tadi satu string je kan? Sini dua string. Okay, the moment it's hanged, what is the keyword that you guys need to know? Tensional force kan? So the moment it's hanged, ada tensional force. Automatically tiada normal force. Kenapa? It is not on a surface. It's not on a surface. It's not touching any surface. Okay. So let me just erase here. Okay. So the moment that is happening, what will be your free body diagram? Your free body diagram will be very simple. Object represented by a dot. What is upwards? Kenapa upwards? Tensional force. Sebab definition cakap always away from the object. Weight force is always downwards. Why? We know very well gravitational acceleration due to daya tarikan bumi always downwards. Okay, this one is quite direct. Jangan worry, just because it has two forces doesn't mean you can't do calculation. Okay, next, for this free body diagram, dekat sini ada dua string kan? The moment there's two different string atau the moment there's two different directions of the string, ini belah sini, ini belah sini kan? So, represent the object with a dot first. Belah kanan, tension 1. Belah atas, tension 2. Please label 1 and 2, okay? Very important. Sebab masa calculation, you guys must show the force is represented by T1 or T2. Okay, jangan lupa anything which is hanging or whatsoever object in the world ada weight force ke bawah, W. Okay. Any questions before I move on to the tips in answering questions for this chapter?
No. CJ,
Yes.
kalau macam buat free body diagram, lepas tu dia bagi angle, kita kena tulis juga kak angle tu.
Oh, not necessarily.
Oh, okay.
Okay. So let me move on to the final part for this session, the tips for answering this kind of question. Number 1, for this chapter, very, very important for you guys to know that, let's say tadi kan tension ke atas, weight ke bawah kan? Okay. T adalah positif, W adalah negatif. Kenapa? Weight force is downwards. Always downwards. So dia akan jadi negatif. Okay. Walaupun dia negatif, because W equals to mg, in this chapter, the moment W, you represent it as negative W. M kamu, let's say 2 kilo. Gravitational acceleration in this chapter is 9.81. Not negative 9.81. Kenapa? You dah represent W dengan negatif. Takkan belah sini pun dah negatif lagi. Kalau negatif jadilah positif. So, you have to represent your W with negative tapi masukkan value 9.81. Kenapa? Dalam soalan dia akan bagi tahu lah panjang-panjang soalan, and then back of the question they'll put bracket. Gravitational acceleration atau AG equals to 9.81. That's why you have to use AG is 9.81, not negative 9.81. But weight force is negative. Sebab dia ke bawah. Represent the negative for W, not for G. G substitute value original. Tadi chapter 2, hari tu chapter 2 memang negatif. That one jangan lupa. Chapter 2 is negative. Chapter 4 represent the symbol with negative. Value dia actual value. The actual value is 9.81. Alright. Jangan nervous or don't really just calm down first. Don't worry about this because we are going to move on the next session for answering questions technique. Okay, that is number 1. Number 2, remember keywords. Keywords we have rough untuk frictional force, FK atau FS. Number 2, we have cable, wire, and rope for tension force. Number 3, push and pull for external force. Okay. These 3 things are very important so that you guys don't get confused what is in there and what is in what are not in it. Okay. Itu nombor 2. Nombor 3 and the last one is the moment something is on inclined plane atau angle is given, you have to resolve vectors. Ingat tu je. Untuk chapter ni, we have a special method. It's called table of forces. I'm going to teach you guys that method. Very useful to answer questions of chapter 4. Alright. Guys, do you guys understand the basic concepts of chapter 4? Any questions?
No.
Okay. Alright. So if there's no questions for this session, so what I would like you guys to do as homeworks is to write down nicely the whole. This is basically all you need for this chapter. You need to know the forces very well. You guys need to write down this as your notes. Please do one by one, step by step. Everything I've explained, please write down in your notes because they are all important. Make like your own notes for this particular chapter. And I would like you guys to pass it up to me. All right, guys. Thank you very much. I hope you guys enjoyed this session. Happy study, guys, and happy doing your notes. Okay, thank you. Let me just stop recording over here first.